Hi, welcome back. Today, let us see how we can do data pre-processing using Knime. So when we say data pre-processing, it's in terms of like, if we have data in two different tables, how do we join the data? If we have to remove some of the redundant variables, how do we remove those features? If there are any missing values, how do we autofill those values? And then if there are any categorical variables in the data, how do we transform them into numerical variables? So these are some of the kind of data pre-processing and transformation that we will see as part of this today's session. So again, to illustrate this hands-on session, we will use a data set of a car manufacturer, and then this data is available in a CSV format. So I will pull in the CSV node to connect the data to the right source. I'm referring it to the data source. So this is my data source. Now, as you see, it's configured. I will execute this, and then we have our table prepared with 395 rows and 9 columns. This is the snapshot of the data. We have 9 columns: miles per gallon, cylinders, displacement, horsepower, weight, acceleration, model year, origin, all represented in numerical format, and car as a string. And then we also see that the horsepower has 6 missing values, and then rest of the descriptive data that you see here. Okay, now if you look at this data, the origin, which is like the number, it has got 3 unique values. If you go back to the table, you see that these values are this category, no, 1, 2, 3. You see these values, right? So these are like it says number, but then this is actually a category. Like what is the make of this? What is the origin of the make of this car? This data is available in a different file, so we will have to map these two files to understand what is the actual origin referring to. So for that, again, that information is also available in a different CVS file. So I'm pulling in the CVS reader and trying to configure the source again. So now this is the data where the mapping of the origin is mapped. One is referring to America, two to Europe, three to Asia. So now I have my both the tables. Okay, I need to map these two tables so that I really get the reference to the category of 1 to 3 in the my original data source. To do this, I will use a join node to join these two tables. I'm using a join node, and then I connect all both the sources, then execute. When I'm like joining, I need to give a mapping, like what is my variable that I need to map. The origin will be mapped to the the origin will be mapped to the origin code of the second table. The first table will have the origin, which I want to map it to the origin code. Then that's how we execute. Now you see, we got the updated table with again 398 rows, but the columns have changed from 9 to 11. You see the new columns, the origin code and the origin name from the second table have been appended to the first table. Now my this is the updated table here. But as you see, now origin code and origin name, all of them are referring to the same data, same feature. I only need origin name because that makes more sense to understand what is the make origin of this car rather than this origin and origin code. So I need to filter out these two columns from the my data source. To do that, I will use a column filter. Okay, so I will pull in the column filter and connect the source. And what is that I'm planning to exclude? No, this my table has all these columns, which is that I want to exclude origin code and origin. I let the remain. Now you see the table is updated again with the 9 columns. The origin code and origin ID has been removed and the original name of the origin name has been retained here. So the so far so good. Now we have data from two tables which has been joined, and then we remove the columns from this, redundant columns from this. Now let us see how what is with help of a data explorer how this data is looking. As you have seen, again I will connect this, execute, open this. As you see now again, now these are all the numerical variables. These are all the categorical variables. Now the origin name has become a categorical variable because we have mapped the 1 to 3 to the actual category, which is the a text string of America, Asia, and Europe. If you see closely here, the horsepower here has six missing values, right? This is what we have seen. But if we want to use this data for any kind of modeling, we will have to replace this missing values with some kind of value so that the model will be able to use these entries. To autofill this values, we will use a missing value node. How do we missing value node? This will help us to give a proper treatment to the missing values. Again, I'm connecting to the source, trying to configure. By default, this dialog box is showing if there are any integers or any floats. How do we want to deal with them? Like, no, there are different options. You do nothing. You want to have a fixed value, min value, maximum value, median, mean, etc. Moving averages. So for now, we want to change any, because the horsepower has been an integer value, we want to change the missing value of a integer with a, let us assume we take the mean, and then we say apply. So now we have done the missing value treatment. If you see the data here, the horsepower has some missing values, right? You see this is the 33 as a missing value. Now after the table has been treated, missing value treatment has been done, let us see what is it showing. You see it is updated with the mean, the 33 row which has missing value is updated with the mean. How do you know this is really the mean? Let us go back to the data explorer and see what was the mean for the horsepower. The horsepower has a mean of 104.4. This is what has been updated. Once again, see with help of data explorer if this has been achieved or not, all the missing values have been updated similarly or not. Again, I correct the source, execute. Now let's see how the statistics looks like. You see the horsepower missing values are being treated. Earlier, before missing value treatment, there was six missing values. Now all of them have been changed. I mean, there are no missing values now. Okay, so far so good. Now that we have combined two tables, joined them, removed the redundant columns, have done a treatment for missing values. Now let us see how do we transform any kind of numerical data into, categorical data into numerical values. So again, if you come back to the columns here, the origin name seems to be a string. But then if we want to use this feature for any of the modeling, this categorical variable has to be a numerical value. So to convert any kind of, that means for whatever the values that we had, right? For each of the column origin name, which was like America, Europe, and Asia, we need to provide some kind of numerical mapping. So this is what we call as one-hot encoding. So here, what we do is every categorical variable is mapped to a numerical combination. So to do that, we use one to many. Okay, and how do you configure this? So now there are two categorical variables, but then I just want to use only the origin name because I don't want to use the car name for my modeling. So that is what will be replaced. Okay, now if you see, now again my table has got appended with the three more columns, which is representing what this America is referring to numerically. In terms of America refers to 100, and then if we see Asia refers to 001 and Europe refers to 010. So this is what we call as one-hot encoding. So every categorical variable is mapped to numerical values. So this is how we do data preprocessing in using Knime.